Okay, today we are still continuing with equations, but we're going to be able to solve something called literal equations today. So I need you to keep in mind that everything we do with literal equations is exactly what we do with regular equations. So take a minute, pause the video, and see if you can answer the warm-up. Okay, so if you had a chance to do that, hopefully you got x equals 2. Remember, when you're solving an equation, you combine any like terms on one side of the equal sign and then look to see if there's any on the other. There are only like terms on the left side today. And then once you combine, you either end up with a two-step or a variables on both sides equation. Okay? Also remembering to distribute first if there were distributing. There was none in this case. So we've been solving equations that contain one variable, either an x, a y, a z, whatever it happens to be. What we're going to be doing today and over the next couple days is solving equations that have more than one variable. That's a literal equation when there's more than one variable. So all it does is it changes the way our answer looks. It doesn't change the way we do anything. It just changes the way our answer looks. So in this example here, it says ax plus b equals 3b. So it has three different letters as an a, a b, and an x, three different variables. So to solve this equation for x, okay, just means get x by itself the same way you would do with numbers. All right, so on this slide, okay, here's that same equation from the previous slide, ax plus b equals 3b. What you want to do in order to understand this is compare this equation to an equation that's simpler, but the same idea. Okay, so since we're solving for x, what you want to do, okay, if you're trying to compare, okay, these two right here, the way we came up with this second one is just replace all the letters with different numbers. Okay, keep x, but replace all of the others with letters. So if I just look at this left equation right here, okay, my first step would be, since it's a simple two-step equation, would be to minus 5 from both sides. Okay, that's going to be our first step. So we'd get 2x equals 10. Over here, I'm going to do the same thing. The 5 is represented by the b, so I'm going to subtract b. So I get rid of the b and I get ax equals, now 3b minus 1b, I can combine to 2b. Sometimes I won't be able to combine, but in this case I am. Over here, now I'm down to a one-step equation. I divide by 2, so x equals 5. Over here, I want to get x alone, so I divide by a, so x equals 2b over a. So the main difference is that our answers look a little bit different. This is a numeric answer. This is an expression answer. So I can't actually have an answer for 2b divided by a, so I just leave it. So just like with regular equations, I can check a literal equation. So this is the check for the easier, simpler, related equation where I plug in 5 and I get the two sides to be equal to each other. Over here, I'm still doing the same thing. I just have to realize, and this is where some people will get hung up, when I have a times 2b over a, when you're multiplying fractions, these cancel out and I just get 2b. So it checks out. Okay, maybe you want to pause this and take a look at it just to see it a little bit in more detail. Okay, so again, this is a literal equation because it has more than one letter in it. So I have x plus a equals b, and I want to solve for x. Okay, it doesn't say those directions, but those are the directions. Solve for x. So if I want to relate it to an equation I know, I leave x, but I change everything else to a different number. So I change the a to a 5 and the b to a 9. If I subtract 5 here, I get x equals 4. Nice and simple. The same thing here. I'm going to subtract a because a is like that 5. The only difference is that I can't do b minus a, so I just leave it b minus a, and that's my answer. So again, this is the literal equation because it has an a, b, and an x. I changed everything that wasn't an x over here to a number. So if I were to solve this, I would add 3x to both sides. So I get 10 equals 5x. And then the same thing over here. I would add, instead of adding 3x, I'm going to add 3ax and add 3ax. So I get ab equals 5ax. Now if I go back over here, I'm going to divide by anything attached to the x because I want to get x alone. The same thing here, so I'm going to divide by that 5, but I'm also going to divide by the a because I need to get rid of both, and they're both attached by multiplication. So I get x equals, now these a's will cancel out, I get x equals b over 5. Okay, so what you should do on this slide is pause it, and if there's an x in the equation, solve for x. If there's a y in the equation, solve for y. So I'm going to pause it, I'm going to do them, and hopefully you can try some and see if you get the same answer. All right, so I did the left-hand column, and really more so for space issues. I didn't do the right-hand column, but try them and then ask in class for those answers when you see me or on the Google Meet. All right, hopefully that's not so bad. Okay, and then you can go and do the delta math and ask any questions that you have.